let's start. Good morning, everyone. And I'm going to show. I'm going to discuss the recent how 14 points support in Android. So we are going to discuss some detail. So the first thing is let's take a real example that emphasizes the importance for 14-point performance in Android. And then we are discussing the API compatibility issues. But in fact, there is no real implementation so far. So everything I discussed just based on some preliminary result and some assumption. Okay, so the last one is how to do some experiment. So I'm going to show one real example, which is SCIA. SCIA is very, very important in Android because it takes care of all of the 2D graphics stuff. So inside Android, there is a service finger. Service finger itself is just to combine 2D and 3D service. So you can see, if you see the final screen is here. So it consists of several components: status bar, the background image, and the launcher icons. Okay. So the service finger just combine this service. Service is a basic area, basic operation area for the graphics. So you can see it just combine the service. So where is the SCIA? SCIA here. So SCIA is a tricky part because inside Android there is a Java package, and the implementation is SCIA. And you can see other parts like OpenGL, which can be selected by hardware. But SCIA is just a library, and it take care of all of the 2D graphics. So this place is 3D, this place is 2D. So if we can improve the performance of SCIA, user can be benefit from it. That's the reason why we are interested in the potential improvement like hardware 14 point. I will refine the presentation so you can see more in detail. So the reason why SCIA exists, for many SoC, there are already 2D and 3D oscillator in modern SoCs. But why does SCIA exist? SCIA itself is CPU bound, so it do computing only in CPU, not in GPU. That is really important. So why was it designed for CPU bound? Because you can think about the case like font. Okay, so if we are going to show the text like nano text, this is a small text. So if you render the text through GPU, you have to pass the drawing command like line this and another line. So you have to pass the drawing command from CPU to GPU, and after GPU send back the piece map, you have to copy it to BMA. So the round trip overhead is visible because you have to do this every time. So for font render, it is better to just render by CPU instead of GPU, right? Because of the overhead. So that's the reason why SCIA exists. So SCIA that doesn't depend on hardware isolation. This is very important because other part like OpenGL can be OpenGL or multimedia can be isolated by hardware. So Google and other vendors like Motorola, SDS, and Qualcomm try to optimize the inner routine in SPIA. So they use SIMD or Neon in bigger SPIA. So the importance of SPIA in Google, at least in Google, is to provide a consistent graphics API to Chrome browser. So SPIA is not only used in Android, but also used in Chrome browser on desktop. So it's try to unify the graphics API. But the interesting thing is recently SPIA supports GPU backend as well. So might be in Android hybrid. I have no idea about the details because no source code available. But we are focused on this fact. So the bottleneck is how we can optimize SPIA and through the potential way, hard floating point. So I'm going to show some basic results. The implementation of deep SPIA supports two kinds of matrix implementation. As you might know, SPIA has several bridge operation and several primitive operation like font rendering. So the matrix operation is very, very important. And there are two kinds of matrix implementation. One is fixed point, another is floating point. So the floating point is accurate, and you can use VFP, which is enabled in ToolChain already. So using floating point might be faster on some machine, but it is not accurate. So in Android, you can define some flag like this, SK underline software float, to indicate you use the floating point. Otherwise, you go into the native. So that's a reference benchmark. Before I joined Linaro, I have one custom in Taiwan. You can see the resolution is very big. It's 720p. It's TV. Google TV like device. Okay. So you can see the result is very, very interesting because SPIA supports two kinds of matrix operation. So you can choose use VFP or use fixed point. So some part is better in fixed point, like this. And some parts is better in VFP. Is for ARM11. So how about our target, the target interest, like on Cortex A8 or A9. So I will show you the latest result. It's Nexus X form, but I never use it as a daily form. I just take it as a event form because it's stable and I can carry it from airport. It's really convenient. I never use it as a mobile phone. So okay, I show you the results. Okay. So it's a Nexus S4. The CPU clock is 1 GHz. ARM Cortex A8, Samsung SoC. So there is a benchmark called there is a benchmark. The name is SPIA bench. So I just use the internal benchmarkers program in Android source 3. Okay. So it's just the benchmark provided by Google. So let's back to the results. The result is a bit interesting. Okay, sorry. Because the resolution is different.
Do control minus.
Control minus. Control minus. No, that's not different. No. Okay. Ouch. So, okay. So.
I think it was better before. That's okay. I think we can see it in the other one.
Okay.
We're smart.
Okay. Just indicate. Okay. So, for uncortex A8, there is VFP-V3. So you can see the benchmark. Just saw the result of FPS because it's the time take to the result. So for fixed point, many developers might think fixed point must be faster than floating point, but it's not true. You can see, it's really hard. Do some editing. So you can see the performance is quite near between fixed point and VFP-V3. The result is very near, and sometimes VFP even faster than fixed point. But the higher floating point implementation is more accurate than fixed point. So you can check the Git commit by Mike Reader. He is the author of SDR, and he is the important graphics guy at Google. So you can see his commit for Cortex or for V7 architecture. So for device under V7, it just uses a fixed point. But for the device supporting V7 or Neon, it will use the VFP instead of software implementation. So it's a trend that it's really interesting that Android is moving to newer device and supports new hardware feature like VFP-V3 because you can see the result that from the result you can have the conclusion VFP-V3 is promising in performance and the correctness. Okay, so it's my sharing for my past experience. So we are thinking the room for further implementation. So till now we still use software FP. Okay. So we still use the software FP API. On recent Uncle we use VFP V3. So the current focus is can we use different API hard floating point to improve Android a bit, maybe a bit, but is a possibility. So and because I have no real implementations so far, the reason is I need the latest toolchain which support latest toolchain include bin utility which support hard floating point. I have to rebuild toolchain, and I have to rebuild libc. I have to rebuild, the graphics part. So in order to make sure the correctness, I think that's the problem. Joy.
So I guess this is open to the tool chain guys.
Because if I want to make sure the incorrectness, I have to recompile some related component, in order to make the system level validation. So that's an open question. So how can we proceed?
Yeah, so I guess that's the question to the toolchain guys, to continue with this experiment, which is an important experiment for Linaro because it can have potentially big impacts. I think it might be a priority from a Linaro perspective to get a toolchain that supports hard floating point. We have to also think about what that means for binary compatibility in Android. But if you can show a significant increase in performance, I think that you can, we can handle those other issues. So, can anybody speak to that from the toolchain group?
Currently the numbers you have indicate that the fixed point implementation is not so far behind BMP, right?
Yeah.
So either the fixed point implementation is terribly bad, so it can't even beat the floating point ones, or this is on the Cortex A8, right?
Yeah. Yeah.
Well, if you've been to any of the Hardfloat session, you'll continuously hear on how the A8 is not very good at floating point to core transfers, especially from the BFA to the core, and how that is solved in the A9. But I currently don't recall any such numbers on the A9. So I'm not sure how much of a real world performance improvement is that, because currently Hardfloat itself is under debate. Well, a lot of guys are pushing it very, very hard, but a lot of the numbers that you see right now are all on Cortex A8. So I'm not really sure on that.
So one thing about that is, a lot of the numbers I've seen are all FPS, right? And FPS is close.
Yes.
But what other aspects if you use like a hard floating point unit, do you get better power?
This is interesting because a lot of people continuously refer to things like GL, but the fact is that, if you look at the GL API, it's mostly, like matrices or vectors of 3 or 4 passed by reference, and that's passed exactly in the same way in hard and soft APIs. It's all passed as a pointer in R0 to R3. So it's only the Scalar arguments that get passed as into the FP registers. So I am not sure of whether it'll be a really good performance improvement. And also, if at the end of we find that the performance is not too great, there's actually another advantage of continuing to use the fixed point ones, because because it's I'm not sure it's implemented yet, but it probably is because I'm not a Girl guy. But from the aspect of lazy FPU context switching, it's better to just leave the FPU alone as much as possible, just for the sake of saving power.
Okay.
So if it's a lot of performance improvement, then maybe it's worth it. But if it's only just like
1% of 1%. Well, it's like 2% or 3%.
It depends. I have indeed seen, from my previous vendor, for some particular benchmarks, not real-world applications, performance improvements of maybe 20 to 30%. But we're talking about if we're talking about graphics APIs, real user experiences. If it doesn't feel more snappy, then
right.
Yeah.
So I think that's the real trick. Is benchmarks are great, but if we can characterize Hardfloat in terms of actual snappiness, because that's a big thing. If something feels, to the user perception is huge. So if something feels more, with a better UI experience, then that's a reason, no matter what the benchmarks say, because they're fake. Not fake, but it's a synthetic measure anyway. So okay, so I guess what are the next steps with this? Because this is, I'm just coming into this thing, but it seems like this has been bubbling for a while, and there's no clear yes, no conclusions, and nothing's been really written up. I think maybe an action item will be to get all of the results together and publish something that says, these are the benchmarks you guys have done, these are the benchmarks you guys have done. And then it sounds like we need to pull in we need to get the new support for the Linaro toolchain so that we can continue doing experiments.
So it's worth it to change API?
We don't know.
Right.
So still question mark.
There has also been a few concerns about whether changing to the Hardfloat API will make the back tracing features more complex, because the arguments are when you have the core registers and arguments placed in both core registers and the FE registers, printing the backtrace will prove to be more complex. You need more information, and even if you do the mark, printing it out in the correct order is harder. But I'm not very familiar with all the backtrace tools, so I can't comment too much on that. Yeah.
So I guess
there has been, I think the power argument has to be taken a little bit more, because like there has been in another context there has been discussions on how whether we should use Neon for mem copy and stuff, and it has been proven to be faster on the A8, but the counter argument is that it just sucks a lot of power. It's just not worth it.
Yeah.
So I think having the power is, so having some write-ups about actual, and that's probably an action item for the power folks, is if these experiments can be bundled up and put into the validation farm, so I think in Hexbench, in Hexbench, do you guys have these experiments integrated into your guys' benchmark, into that benchmarks?
We have the 2D and 3D bench.
Okay.
So you can reflect the performance of OpenGL and scale.
Okay. So.
But it's a synthetic benchmark. It's not a real user application benchmark.
Yeah, but we can do so we're going to get power numbers for stuff, and that would actually be an interesting thing, right? Is to actually produce that matrix that shows the trade-off there for power versus performance, because it's going to be, it's all going to be more power. It's probably going to be what, 10% more. I mean, you are well, maybe not 10, but you are turning on a big chunk of hardware. It's not free. And then we had another, so the other action item is, you know, this support for dual ABI, because you'd need to load 2 different libraries depending on where you're at, which, I don't know, is there support for that?
For 1% improvement.
For 1% improvement, we have to make changes to like 20 different interfaces and have a sensing of this. Okay.
Can you like easily rebuild a LED image just by turning the switches, changing the entire thing to Hardfloat? Can you do that?
I think I think I can do that. But I lack toolchain.
Yeah. Toolchain, you lack a Hardfloat toolchain?
Right.
Yeah, but I have old because for some reason, I can only use all the bin utility. I show you something. Okay, wait a moment. Like this. Toolchain. Because because the bug. Yeah, this. So there is a pre-link in Android. So the pre-link try to analyze the year of executable. And if I use recent bin utility, yeah, this. If I use a recent bin utility, the pre-link in Android will fail. Because it detects empty symbols in symbol table. Yeah.
Does this occur even in the upstream CBS versions?
Okay. I just tried some combination because I just doing February. I didn't try the newer bin utility. Because there is no bin utility maintained in out now, so I just use the upstream. So the result is loose rate change. Because you can see new version there, Google's version, which is old, succeed, code associate there.
Sorry.
So it is a crime that because Google has many low-level utility, like a pre-linker, like a tool which replaces strip due to license issue. Google just rewrites some application. But we don't know the development direction about Google engineer. So sometimes we will encounter this. So the workaround is just use the older version. So it's very stupid, but
well, currently, there are 2 versions of so-called upstream finding tools. One is the FSF one you get on the new.org, and the other one is the sjlu one from kernel.org. You can get over there. The co-sorcery ones are based on the sjlu, so you can tell that from the 51 minor version. Maybe you can try a newer version of the sjlu distribution. He updates his own release more frequently. The FSF ones are seems to be less frequently updated. And well, for experimental purposes, you might try out the CBS checkouts.
So yeah. So yeah, I agree that I should try to build version again and verify again. So that's it.
So one thing, in addition to the benchmarks, is to see if you can quantify snappiness in any way automatically. So let's take like an in real life. I guess that'd be a user experience. Whoops.
So what is here? Instead of upper. I just curious about why this line here.
I think someone asked them during the sessions. I was in one meeting where someone came in from outside. I don't know.
Okay.
Yeah, is anybody coming in from the?
There's no one online.
No, they might be. Somebody's listening in from outside.
I think there's
Show yourself.
to be able to find it later.
Yeah. Okay, so we've got a couple of good, I think these are good action items. One thing I think we gotta do is, right now it's all really amorphous. So, Jim, maybe what you can do is start to collect all the results from everyone.
Not sure because in fact I have no background knowledge about the hardware floating point.
Sure.
Is changed. Yeah, I just checking the page because for Ubuntu and Debian there is a page for the status about integration. You can see once you switch to Hardfloat, more and more trouble.
Yeah.
I encounter.
But what I mean is, right now, there's no work product. It's all this person saying this and this person running this benchmark. There's no common place where, and maybe that common place is the OX bench in Android, where we can actually have all of those and make it easy for people to run these experiments and make it easy to do an LEB build and turn the features on and off. So if you could collect things up, and we'll actually come to some conclusion on that, and then we can give that to Octo, and they can, I'm sure it's going to be one of these things. Well, we'll integrate it into the benches, we'll run the test benches, and if you start to see big improvements, then we'll start to push those out. So I think it's just going to be a, let's get the benches in place. Let's get the reporting numbers, let's get the current numbers, and then on an ongoing basis we'll be able to see whether we're doing better or worse. So maybe we have LEB Panda, hard floating point, build, things like that, to make things, because those are easy to generate with the infrastructure. The changes are pretty huge, but just from a getting the builds perspective, I think we can solve that problem. Okay.
So is there any available benchmark or test program for hardware floating point?
I guess toolchain guys?
That's a good question. We're looking for these. We've also recently heard some like some cases, some very extreme cases where there is like 2-3 times performance difference between soft FP and hardfloat, and we're like, what? and it's still highly reliable, and also there's also the whether you're using Cortex A8 or A9 questions involved. It's just sort of unclear, and also there are also issues like, for example, the call organization of your program, because GCC currently has a capability like for example, if the floating point functions are like, you know, static and can be optimized by GCC to be contained, then it will automatically turn it inside into Hardfloat because the function is not exposed to outside, and that will get better with more inlining and potentially in the future with LTO.
Mm-hmm.
And so this will change a lot because the concept of Hardfloat helping floating point performance is purely just in moving values. It will change a lot according to the application. And so for, you know, and even for an application where it does matter, who knows, after a few organizations, you know, it's really quite unstable.
Well, the one thing that I think we can do is collect any benches we have up, make sure that they run on Ubuntu and Android, which the OX bench stuff is already running benchmarks, you know, your more typical benchmarks in Android. So I think we can do that, and then to actually present a page kind of like status that actually gives, you know, kind of the current status of the floating point experiments, because then we can have something we can point to and say, well, here, these are the benchmarks we're running. So which benchmarks are you running, Mr. 2X Performance? Oh, I just ran this thing, and I don't know. I'm going to go away now. I'm sorry for talking.
Exactly. I think it's a very good point. I think we shouldn't run any benchmark. I think we should choose first what the benchmark you want to run. You should choose what exactly you want to measure and what is important for you, not for the toolchain guy, for you, for your Android. What do you want to measure? Because if you measure the toolchain, I guess you don't care. What you care is what will be the user experience.
Well, that's ultimately the big thing, right? Is if it feels snappy and it looks snappy, it's a good change, and that might not come out of the benchmark. I don't know.
Yeah, I think you should try to pick benchmarks that matter to you. I mean, in your context, try to make, you know, maybe make something out of the Android code. You know, something that you're, you know, at least have some confidence that if this is improved by Hardfloat, then so will the user experience.
Well, I think I agree there, though. When we compare, we need to have tests that run across the distributions, so that we can kind of, I mean, they should obviously run the same, right? Same hardware. They won't. But anyway, then we can compare apples to apples. And anyway, you know, we have to do it for both anyway. So, but no, I think it's a valid point. Is, you know, I think in the Android case we also have the, okay, well, even in the Ubuntu case, right? You still have, you know, there you're using Qt, for example, but in Android you're using, you know, Surface Flinger and the whole thing. But it's still UI. It's still, you know. Because then actually, that's actually a really cool thing, right? Because you could say, well, what UI are you running on Ubuntu embedded? Because it feels much better than Android, or vice versa. You know, oh, Android feels much more snappy than Qt under the exact same benchmarks. And that's something that Linaro is perfectly suited to, well, Linaro Canonical is perfectly suited to figure out. So if we can get the common set of benchmarks and, you know, the Android platform team through OX Lab, I think that'll be a really good use of our time to pull that together and to help facilitate that conversation a little bit, because it's all an email and it's all hearsay and it's all, I have this piece of information and you don't, and I'm running my benchmarks 3x faster. That number's going to keep going up, by the way, as we talk. We'll be like 100x faster by the time we're done.
In my opinion,
I'm going to post that to Slashdot.
in my opinion, there are two essential libraries we can evaluate. One is SCIA, another is WebKit. The two libraries has no other dependency, and they are computing bound.
So you can use WebKit, you can use a web browser page selector.
Yeah.
So that's
and
it's doing on Ubuntu as well.
Yeah, the WebKit has its own benchmarks. proven.
Yeah,
But
sounds
the
good.
problem is how to read the results from the bench. Some are better, some are worse, and we need the overall idea.
But I think, Jim, I don't think it actually matters. I think what matters more is not to interpret the results, but to present the results.
Yeah.
And to just do it on a continuous basis. That's more important because people will come to their own judgment about it, you know. So just put them up there and just say, this is it. This is what LEB build X was, and this is what LEB FB was, and this is Skia, and this is, you know, and these were the results.
Theoretically, Hardfloat won't, you know, you showed results where there were varied between the soft and the FPU modes, but theoretically, Hardfloat will not be worse than soft FP. It's just by how much. You know what I mean? It's like it may be 1%, it may be 10%.
What would be good, it would be good to have that as an item or an action is to make sure that we test on both Cortex A8 and Cortex A9.
Yeah.
Because they are completely two different CPUs in that respect. So what can work well on A9 might not work as well on A8, so it would be good to know.
And multi-core, of course, too, because that's going to change your results when we have lovely multi-core targets.
Right, but that shouldn't, I wouldn't think that would change, like if you run soft FP on an SMP system and then you run hard FP in the SMP system, hard FP in the SMP comes into that, does it?
You don't think so?
Like,
Because one of
it's just the ADI, isn't it?
Yes, the SMP should not matter.
No.
These are just single.
I mean, if you compare
single thread.
compare SMP to UP, there's obviously a difference, but that's not what we're measuring.
No, I know, but even kind of, you don't think there's a system-wide effect of, I mean, if you're compute bound, right, and you're on an SMP system, then you're going to feel snappier than if you're on a UP system, because the UP system is going to go off and it's going to sit in that loop.
Well, I just don't see how hard FP has anything to do with that.
Well, hard FP,
Well, maybe if.
well, so here's another thing, right, is memory utilization, right? So does hard FP utilize the memory more or less? Or is it all kept within the core?
But if you compare UP against MP, yes, but otherwise, if you compare Softfloat and
Yeah, I think if you try and add SMP in there as well, it's just another thing to worry about, which I don't think, when it comes down to it, it's not really going to affect it that much. That's all.
Perhaps. I mean, of course, we're going to have if we get this test set up right, we're going to test A8 and A9, and we'll put in SMP. We'll test it.
Yeah, I'm
know.
not saying you shouldn't. I just don't think that it's worth making a deal of that.
Okay. Well, I think that, I mean, you know, with these systems, they're so complex and there's so much going on that, you know, what's actually making the difference tends to be hard to figure out. But yeah, I mean, you know, you can look at the benchmarks for just in general, and if you see 2x performance across the board, then you know that, you know, come on, 4x, 20x. Quad core ARM. Oh. Actually, we're going to see some quad core ARM products coming out pretty soon. That should be unique. All right.
Another thing is the approach to make real experiment. Because Android is a complete operating system, totally different from Debian or from Ubuntu, which is configurable. Android is not configurable. You have to make everything available in order to show hello world. Because you have to prepare Bionic, libc, Basic VM, Android framework, graphics, network, blah 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 blah, and so on, in order to show the hello world application.
Yeah.
So I think this part, how to make the experiment is important, because we not only to watch it, but also how can we recognize okay, we resolved the problem when we rebuilt libc, bionic libc, and including some problem like David VM. Yeah. I have no idea which parts are hard-coded. You can see in David. It's just because in David VM there are many hard-coded variables. So I didn't look into detail, but it did generate the VFP instructions.
Right, but since this is an API issue, isn't your only concern if it's generating code which compile code has to interact with?
Yeah, but
we wouldn't be doing that.
Yeah, but it generates VFP instruction. Also the order of the parameter API.
So I guess, what are you saying, Jim, that JIT is going to have a big impact?
No, JIT itself has the assumption for API, right?
Okay.
So you're saying that you also have to implement the Hardfloat API again for the JIT?
Yeah.
Oh yes.
Otherwise, it won't work, right?
I've done things like that several times before.
Okay.
So is there an action item there? What's the action item there?
But I can disable it totally.
Okay.
Disable JIT.
Okay.
But disabling the JIT makes things
And then you benchmark.
unrealistic. Yeah.
Every-
It's not fair on the benchmarks
Yeah.
at all, because you say, here's my software PA, like, oh, I enabled Hardfloat. Oh, by the way, I turned off the
Yeah.
JIT.
So
Put that in very little font. Nobody reads that.
It depends what you benchmark. If it's the browser, it's not using the JIT. It's not using Dalvik. It's native.
yeah.
JavaScript driven from the top.
So maybe the issue there is to just characterize, is to just make sure that, you know, if it is a JIT test, we point that out. If there's changes that have to be made there to do hard floating point JIT versus not.
Right, well, ultimately this is also something you probably want to measure, right? So if the JIT is generating VFP instructions, it's probably quite interesting to see how that is affected between the APIs.
Oh,
so
yeah.
That's another reason not for just turning it off, because it's actually a piece of software which is using VFP.
Right, right. No, I agree with that.
Are the upstream Google developers interested in doing this sort of thing? Adding hardfloat support to the JITs.
You know, our approach to that, not having relationships with them, is, well, not yet anyway. Our approach to that is these easy to produce benchmarks, these easy to produce builds, these places where, you know, our job as platform is to kind of make it easy to communicate all of these things and to do these experiments. You know, and OXBench is a perfect example of something that is easy to use. You can throw it down, you can get results, and we can simply co-locate those results on some web page. And if we find interesting things, so the whole goal is, if we find interesting things, we shove them upstream. If they're not interesting, we don't worry about it. We're not going to just shove changes up to shove changes up. It doesn't make any damn sense. It just causes a bunch of churn. But if we can honestly point to something that has 10x performance or something like that, then the idea is that then that's justification in and of itself. And you know, if we can come up with lots of those things, well, then we'll build our relationship and so on and so forth. So it's just like anything else.
About the if you can identify the interfaces in and out of the JIT, there is support within GCC to, like, you know, you're in a Hardfloat environment, but you can change particular interfaces to use, you know, using the attribute stuff. You can change to softFP for those interfaces. So if you can identify them, then that might be a compromise.
Okay.
Right, but that still goes back to what I said earlier. So if you're benchmarking these two things, it
Well,
still looks
yeah,
right.
it's a compromise.
We're benchmarking
It's better than turning off the JIT, right?
Yeah, it's a lot better than that.
So-
it's still not a very good thing for doing benchmarking.
Before we get done, why don't you guys get together and have a chat, and because you guys are all going to be working together, I guess, and just come up with a plan for what you know, ideally what you want to do, and then we'll get the infrastructure and everything set up, and we'll make it easy, and it'll be fun. Okay? Sound good? All right. Thanks, everybody. Appreciate it.